Chapter 5: How Air Pressure Affects Weather. This chapter is dedicated to understanding the role of air pressure and the way this change plays a crucial role in shaping weather conditions. Let us first begin by understanding what is air pressure. It basically refers to the volume of air in a particular environment, with greater volumes creating higher pressures. On the Earth's surface, for example, it is known as atmospheric pressure and refers to the weight of Earth's atmosphere pressing down on everything. Changes in pressure can impact the temperature, weather patterns, and cause physiological problems for people and animals. This pressure can even impact the performance of a basketball or similarly inflated objects. It is essentially the force that is exerted at a specific point on the surface of the Earth by the weight of air molecules that is above it. Although the air molecules are invisible, they have weight and they do take up space. Since there is a lot of space between air molecules, air can be compressed to fit in smaller volumes. When compressed, air is said to be under high pressure. Air at sea level is what we are used to. In fact, we are so used to it that we forget we are actually feeling air pressure all the time. High pressure situations are generally associated with fair, sunny weather. Low pressure areas are generally cloudy or rainy, where strong areas of low pressure bring out stormiest weather. That's because as air rises, it condenses into clouds and rain. Air moves from higher pressure to lower pressure, so if you have a high and low nearby, it can be windy as air rushes between the two. Let us now look at the relation between pressure and weather in different settings. First, on Earth's surface. Atmospheric pressure varies slightly over the Earth's surface, and variations in pressure are responsible for various types of weather. Low pressure systems are associated with storms, tornadoes, and hurricanes. Sometimes the air pressure at sea level can drop as low as 870 millibars on the barometer, which is about 85% of average air pressure. This only happens during the most severe storms. Pressure variations on the Earth's surface causes wind, as high pressure air moves towards low pressure air, creating gusts. Second, at different altitudes. On the top of Mount Everest, the tallest mountain on Earth, the air pressure is just about a third of what it is at sea level. Humans at high altitudes often experience discomfort such as ear popping due to difference in their internal and external pressures. At 16 kilometers or about 10 miles above the surface, slightly higher than the cruising altitude of a typical jetliner, pressure is only 1/10 of what it is at sea level. Because low air pressure can be very unpleasant for humans due to low oxygen content, all areas of aircraft that contain passengers are artificially pressurized. Third, on higher altitudes and outer space. At 31 kilometers or about 19 miles above the Earth's surface in the stratosphere, the air pressure is only 1/100th of what it is at sea level. From this level on, the atmosphere quickly decreases into nothingness. Above 100 kilometers or just over 62 miles above the surface, the international definition of outer space, the pressure approaches zero and nearly becomes vacuum. Humans cannot exist unprotected in such a low pressure environment. Fourth, high pressure settings. Beneath sea levels of the Earth, pressure becomes increasingly greater. Under the ocean, for example, high pressure in the water can crush a person or object that is designed to withstand the atmospheric pressure of the planet. Special suits and vehicles are needed to withstand such high pressures. The role of pressure on weather is quite an interesting one. The presence of air in different settings not just helps you understand the air pressure level of the place, but helps in expecting the effect it has in the region. At the end of this chapter, you are able to relate the effect of air pressure, humidity, and temperature on weather.